Hi everybody, welcome to my general math presentation number 4. We are going to talk about logarithms and how are we going to apply it in real life situations. In this first slide, this is an example of a logarithmic equation. So the logarithmic equation is log x3 is equal to 1 over 3. We are going to find x by turning it into an exponential equation, which will be x raised to 1/3 is equal to 3. We're going to multiply both sides of the equations to raise to 3 so that we will get x is equal to 3 raised to 3, which will then give us x is equal to 27. So this is an example of a logarithmic equation that is used in real-life situations, such as converting intensity to magnitude. So we have an earthquake is measured with wave amplitude of 1000 times as great as I sub 0. What is its magnitude using the Richter scale? So the formula we're going to use is magnitude is equal to log the given intensity over I sub 0. So we're going to substitute the values that we have. So magnitude is equal to log 1000. Since the given intensity is 1000 times greater than I sub O, we're going to use 1000 I sub 0 over I sub 0. We're going to cancel both I sub 0s, and then we will get log 1000, which is equivalent to 3.0. This is another example of how can we use logarithmic equations to real-life situations, converting pH level to hydrogen ion concentrations. So the problem we have is a sample of rainwater was determined to have a pH of 6.35. What were the H plus concentrations of the sample? So the formula we're going to use is log H plus is equal to the negative given pH. So we're going to use log H plus equals negative 6.35, and then if we're going to find for H plus, the answer will be 4.47 times 10 raised to negative 7. In this next problem, we're going to use logarithmic equations to convert watts per meter squared to decibels. So the problem is, what is the decibel rating of the sound of an orchestra playing a movement for pianissimo at 8.6 times 10 raised to negative 5 watts per meter squared? So we're going to use the formula decibel is equal to 10 log the given watts per meter squared over 1 times 10 raised to negative 12 watts per meter squared. So we're going to substitute the values that we have. So we have 10 log 8.6 times 10 raised to negative 5 watts per meter squared over 1 times 10 raised to negative 12 watts per meter squared. If we evaluate the problem, we will get the decibel is equal to 79. So that pretty much explains what the worksheet is about for this week. Hope you learned something. Thank you.